Okay, so today we are going to be talking about solving systems of equations by substitution. Method one was graphing, so method two is now substitution. And again, there are three methods, and each one works best for specific situations. So, substitution works best if one equation is solved for a variable. And what that means is that at least one of your functions, rather, or equations, is in like slope intercept form, right? So y equals mx plus b form, because the y is already by itself and it makes it much, much easier to substitute. Okay, so one equation has to be solved for a variable. It works best if that's the case. So step one, you are going to substitute one variable in a function with the other function. And again, we're just going to copy the steps for right now, and then it'll make more sense when we actually go through the examples. So you're going to substitute one variable. You're going to replace one variable in one function with the entire other function. Okay. You are going to simplify if you need to. And then because now you only have one variable in an equation, you are going to solve for that one variable. And then you are going to substitute again. So you're going to, when you solve for that one variable, you're going to substitute that answer back into one of your functions and solve for the other variable. So again, go ahead and get those steps down. And again, they'll make a little bit more sense when you see the steps that we're doing. All right, so example one. Okay, so step one, we are going to substitute. So we have to replace a variable in one function with the entire other function. Now, these are both in what we would call slope-intercept form. So there's something actually really neat that happens with these. I am going to replace the y value. This first function says that y equals 3x minus 2. The second function says that y equals negative 2x plus 8. Well, since y equals y, that means that 3x minus 2 also equals negative 2x plus 8. So there's my substitution step. I don't need to simplify. There is nothing that needs to be simplified here, but take a look. I now only have one variable in this equation, right? Because I can't solve an equation that's got two variables in it, right? I have to get rid of one of the variables somehow. So this is one of the methods. So now I have an equation that has variables on both sides. And again, we're just going to use inverse operations to go ahead and solve it. So I'm going to add 2x to both sides. I've said this before that I don't like having negative variables if possible. So I'm always going to move the smaller of the two variables so that I don't have negatives. So 3x plus 2x is equal to 5x minus 2. Negative 2x plus 2x is 0, so it's a 0 pair, so that just equals 8. And then I'm going to add 2 to both sides. And by the way, yes, this is step 3. I am solving. Okay, so now I have 5x, that's a 0 pair, equals 10. And if I divide by 5 on both sides, I get x is equal to 2. Okay, so I have solved for one variable using the equation. And now I am going to substitute that x that I solved for back into one of my original functions. And it does not matter which one, because remember, the point is you're trying to find the solution that's true for both of them, right? So it doesn't matter which function. So I'm going to take x equals 2 and substitute it back in. If I substitute it into my first one, then I get y equals 3 times 2 minus 2. And then I'm going to solve for my other variable. So 3 times 2 is 6, minus 2 is 4. So I have now solved for my other variable. The only thing I have left is to make sure I write my answer as an ordered pair, because it is a specific point, an x and a y value, that solves this. So my ordered pair point is 2, 4. So for both of these equations, what I am saying is that when x is 2, y will be 4. And if I were to graph them, that is where that they would intersect. All right, so let's try another. Hopefully that helps as far as the steps go. All right, so same thing. First step is to substitute. Now in this case, only one equation is solved for a variable. So this substitution, very specific, since y equals 2x plus 1, I'm going to make the other y also equal 2x plus 1. So I'm going to substitute it in. Now watch. The 2x doesn't change. The negative 11 doesn't change. Okay, what changes is that I am multiplying this negative 3, because it's negative 3 times y. This negative 3 gets multiplied by this whole thing, because I'm replacing the y with 2x plus 1. And since I'm multiplying more than one piece, I know I have to distribute. So in this case, I am going to have to simplify my equation. So 2x, and then I have to distribute my negative 3. So that's a negative 6x. And yes, that is a negative 3. That's why there's a negative or minus sign in front of it. So I am distributing the negative 3. Minus 3, negative 3 times 1 equals negative 11. Simplified a little bit more, I can combine my like terms. I have 2x and negative 6x. That's negative 4x. Minus 3 equals negative 11. So I have substituted and simplified. That's steps 1 and 2. Okay, third step is to actually solve for the variable now. So now I can go through and actually solve the equation because it's in a form that I can deal with. So I'm going to add 3. And again, I could have divided by negative 4, but that's going to be some really ugly fractions because I got to divide everything. So for this problem, it's just easier to go ahead and add 3. So negative 4x, that's a 0 pair, so it's gone. Negative 11 plus 3 is negative 8. And now I'm going to divide, and I'm going to get that x is equal to 2. Okay, so next step, we're going to substitute again. We're going to substitute 2 for x back in one of our original functions. Now again, it doesn't matter which one, but in this case, one would actually be easier than the other. The first equation would actually be easier to work with because the y is already by itself and you don't have to do as much solving. Now, is it wrong to put it in the second one? No, it's not. You just have to do a couple of steps to solve. I'm going to use the first one, and that is going to be that y equals 2 times 2 plus 1. So in this case, y is equal to 5. Now, if you were to substitute into the other function, again, it's not wrong. You would have 2 times 2 for the 2x minus 3y equals negative 11. That's 4 minus 3y equals negative 11. I would subtract 4 from both sides, right? So 4 minus 3y, negative 11 minus 4. That's going to be negative 3y equals negative 15. And if I divide, I'm still going to get y is equal to 5. So it really does not matter which one you substitute back in, because you're going to get the same answer. It's just, again, one's a little bit more work than the other. So the ordered pair for my solution is 2, 5. All right, let's try one more. Okay, so take a look. In this equation, or in this system rather, x is solved for, and that's okay. You can substitute x just as well as you substitute the other way. So I'm going to do the same thing. Since x equals 2y minus 3, I'm going to make this x also equal 2y minus 3. So that's going to be 2 times 2y minus 3, since that is 2 times x, multiplying by the whole thing. The plus y doesn't change, and neither does the 9. So I've rewritten that second function, and I've changed x. I've substituted x and made it 2y minus 3. So I've done my substituting. Now I'm going to simplify. I need to distribute my 2. And I need to combine my like terms. I have a 4y and a 1y. So that's 5y minus 6 equals 9. Okay, so I've done substitute and I've done simplify. And now I'm going to solve my equation. So I'm going to, again, add 6 to both sides because dividing by 5 would give me very nasty fractions. So 5y, that's a 0 pair, equals 15. Divide by 5, and I get 3. Now, be really careful when you substitute this back in. Remember that you're substituting for y this time because that was the variable that you got. Okay, so pick whichever function you want to do. If you do the first one, it's going to be x is equal to 2 times 3 minus 3. And that means x is going to equal 3. If you do it in the second one, it's going to be 2x plus 3 equals 9, and then you have to subtract 3 and divide by 2, but you're still going to get 3. So my ordered pair in this case is 3, 3. And that is it for solving by substitution. Our next video will be solving by elimination.